Across the vast expanse of the universe, there exist immense clouds of gas and dust. These clouds, often stretching across light years, are the raw materials from which stars are born. They float silently in the cosmic void, waiting for the right conditions to ignite the process of star formation. These cosmic clouds, known as nebulae, are the birthplaces of stars. Nebulae are not just random collections of gas and dust. They are the cradles of new stars, where the delicate balance of forces leads to the creation of these luminous celestial bodies. Imagine a canvas painted with swirls of crimson, emerald, and azure. These vibrant colors are not just for show. They tell a story of the elements within the nebula. Each hue represents different gases and elements, creating a cosmic palette that is both beautiful and scientifically significant. These colors represent the hydrogen, helium, and other trace elements that make up these incredible structures. Hydrogen, the most abundant element in the universe, glows with a characteristic red hue, while helium adds a touch of blue. Other elements, like oxygen and sulfur, contribute to the rich tapestry of colors. Gravity, the architect of the cosmos, draws this material inward, slowly at first, then with increasing speed. This relentless force pulls the gas and dust together, initiating the complex dance that will eventually lead to the birth of a star. As gravity pulls the gas and dust together, the cloud begins to collapse. This collapse is not uniform. It happens in pockets where the density of material is higher. These pockets become the seeds of new stars, where the conditions are just right for nuclear fusion to ignite. This collapse causes regions within the nebula to become denser. As these regions grow denser, they attract even more material, creating a runaway effect that accelerates the process of star formation. Picture a snowball rolling down a hill, gathering more snow as it goes, growing larger and larger. This is similar to how these dense regions within a nebula gather more gas and dust, increasing in mass and density. The denser regions within the nebula act as seeds, attracting more and more material. As they grow, the pressure and temperature at their cores increase, setting the stage for the next phase of star formation. This process releases heat, causing the temperature at the core of these collapsing regions to rise dramatically. When the core temperature reaches millions of degrees, nuclear fusion begins and a new star is born. The nebulae themselves are not uniform. They are vast and varied, with regions of different densities and compositions. This diversity leads to a wide range of star types and sizes, each with its own unique characteristics. They are sculpted by shock waves from exploding stars and the powerful winds of newborn stars. These forces shape the nebulae, creating intricate structures and triggering new waves of star formation. These processes create pockets of higher density within the nebulae. These pockets are the nurseries where new stars are born, each one a potential new sun in the vast expanse of space. These pockets are where star formation begins. Within these dense regions, the conditions are just right for nuclear fusion to ignite, leading to the birth of a new star. It's a chaotic and beautiful dance, a delicate interplay between gravity, pressure, and the raw materials of the universe. This dance is what leads to the creation of stars, planets, and ultimately, the building blocks of life. The Eagle Nebula, with its iconic pillars of creation, is a breathtaking example. These towering columns of gas and dust are the birthplaces of new stars, sculpted by the forces of gravity and stellar winds. This nebula showcases the sheer scale and beauty of star formation. The pillars of creation are just one part of this vast region, where countless stars are being born. The Hubble telescope has captured stunning images of these pillars, revealing intricate details of the celestial nursery. These images allow us to peer into the heart of star formation, witnessing the birth of stars in real time. These images serve as a powerful reminder of the dynamic and ever-evolving nature of the universe. They show us that the cosmos is not static, but a place of constant change and creation, where new stars are born and old ones fade away. Deep within the collapsing cloud, a protostar begins to form. This is the very first stage in the life of a star, a moment of birth that is both delicate and powerful. No longer a diffuse cloud of gas and dust, the protostar is a distinct entity, its core growing hotter and denser by the moment. The transformation from a mere cloud to a solid core is a remarkable process, driven by the relentless force of gravity. Surrounding this nascent star is a swirling disk of leftover material. This disk is a chaotic mix of gas and dust, constantly in motion, influenced by the gravitational pull of the forming star. This disk, known as a protoplanetary disk, will eventually coalesce to form planets, moons, and asteroids. Over time, these particles will collide and stick together, gradually building up larger and larger bodies. Think of the protostar as a glowing ember, hidden within the heart of a collapsing cloud of smoke. It is a beacon of potential, a small but significant source of light in the vast darkness of space. It emits light and heat, but it is not yet a true star. The energy it radiates is a result of the gravitational contraction, not nuclear fusion. The protostar's intense gravity continues to draw in material from its surroundings, causing it to grow larger and hotter. This accretion process is crucial for the protostar's development, as it gathers the mass needed to eventually ignite nuclear fusion. As more and more material falls onto the protostar, its core temperature and pressure continue to rise. The core must reach a critical temperature and pressure for nuclear fusion to begin. This period of intense growth and heating can last for millions of years. It is a slow and steady process, with the protostar gradually accumulating mass and energy. During this time, the protostar is a dynamic and ever-changing object. It is not a static entity, but one that is constantly evolving, with its appearance and behavior shifting as it grows. It flickers and flares as it accretes material from its surroundings. These flares are bursts of energy released as the protostar's gravity pulls in more gas and dust. The surrounding disk of gas and dust also evolves, forming rings, gaps, and clumps. These structures are the precursors to planets, moons, and other celestial bodies. These structures hint at the formation of planets and other celestial bodies. The clumps of material within the disk are the building blocks of future worlds. The birth of a star is a long and drawn-out process. It is a journey that takes millions of years, with each stage building upon the last. It is a testament to the patient hand of gravity, slowly sculpting these celestial objects from the raw materials of the cosmos. Gravity is the unseen artist, shaping and molding the gas and dust into a new star. These protostars, hidden within their dusty cocoons, hold the promise of light and heat, waiting for the moment they will ignite and take their place among the stars. They are the seeds of light in the dusty cosmos, the beginnings of new stars that will one day shine brightly in the night sky. Deep within the heart of the protostar, a critical threshold is reached. This is a moment of profound transformation, a turning point in the cosmic dance of creation. The temperature and pressure become so intense that a remarkable transformation takes place. Nuclear fusion ignites. This ignition is not just a simple spark, it is a monumental event that signifies the birth of a new star. This is the defining moment in the life of a star, the moment it truly comes alive. The star begins to shine, casting its light across the vast expanse of space, marking its presence in the universe. Imagine a dormant volcano, its fiery potential hidden beneath the surface. For eons it remains quiet, its power contained and unseen. Suddenly the pressure becomes too great and the volcano erupts with incredible force. The once silent giant now roars, releasing its pent-up energy in a spectacular display. Nuclear fusion is the process by which lighter elements such as hydrogen are fused together to form heavier elements such as helium. This fusion process is the very heart of a star's energy production. This process releases an incredible amount of energy, which is what powers the star. The energy radiates outward, providing the light and heat that we see from Earth. The immense pressure and heat within the star's core act like a cosmic pressure cooker, forcing hydrogen atoms to overcome their natural repulsion and fuse together. This fusion is a continuous process, sustaining the star's brilliance. This fusion process is a delicate balancing act. The star must maintain a precise equilibrium to continue shining. The outward pressure from the nuclear reactions in the core pushes against the inward pull of gravity. This balance is crucial for the star's stability. For most of a star's life, these two forces are in equilibrium, creating a stable star. This stability allows the star to shine steadily for millions, even billions of years. This balance is what allows stars to shine for millions, even billions of years. The light from these stars travels across the cosmos, reaching us as twinkling points in the night sky. The ignition of nuclear fusion marks the birth of a star. This moment is the beginning of a new chapter in the star's life, a chapter that will last for eons. The once dark protostar bursts into life, radiating light and heat into the surrounding cosmos. This transformation is a testament to the incredible power and beauty of the universe. It is a beacon in the darkness, a testament to the incredible power of the universe. The star's light serves as a guide, illuminating the path for future generations of stars and planets. From this point forward, the star will continue to fuse hydrogen into helium, releasing energy and illuminating the cosmos. This process will sustain the star for the majority of its life, allowing it to shine brightly and influence the universe around it. The journey of a star is a long and fascinating one, from its fiery birth to its eventual demise. Each stage of its life is marked by incredible transformations and the release of vast amounts of energy. And when a star's life finally comes to an end, it does so in a spectacular fashion, often exploding in a supernova, scattering its elements across the cosmos, seeding the next generation of stars and planets. The remnants of these stellar explosions become the building blocks for new stars, continuing the cycle of creation and destruction that defines our universe. In this way, the life and death of stars are interconnected, each one playing a part in the grand tapestry of the cosmos. The nuclear heart of a star is not just a source of light and heat, but a key player in the ongoing story of the universe. As we gaze up at the night sky, we are reminded of the incredible processes that take place within these distant stars. Their light tells a story of creation, balance and transformation, a story that has been unfolding for billions of years. Each star is a testament to the power of nuclear fusion, a process that not only powers the stars but also creates the elements that make up everything we see around us. The Milky Way, our home galaxy, is filled with countless stars, each one a nuclear furnace, contributing to the light and energy that fills the cosmos. The universe is a vast and wondrous place, and the stars are its beating heart, each one a testament to the incredible power and beauty of nuclear fusion.